Harris here. I am here to show you how to take the volume of an irregular shape through water displacement. So Eureka is what you're going to say after this video. And this video will be available for you forever. So you can watch it as many times as you need to, rewind it, go to different places, or pause it as you're doing your work so that you can kind of go through. We're going to do this Dora the Explorer style, kind of, okay? So again, Eureka means in Greek, basically, I understand it, or I've got it. So again, hopefully you say that at the end of this. So graduated cylinders are something you've probably seen before. We use them a lot in science to be able to find volume, and that's how we measure volume easily. We use the meniscus, so you can see in this image that we've got on the side, that meniscus is the lowest point. So whenever you get at eye level, you'll see that the water isn't just straight across and hits exactly where. It actually bends down a little bit, and you can see that lowest point is what we need to measure. It's kind of a trick of the light. It's kind of like whenever you're swimming and you look and your hands and your feet look a little different in the pool. It's because that light is going to bend a little bit. So again, we measure from the lowest point, which is the meniscus, when using a graduated cylinder or anything really. If you're a big baker, then you already know this. Pay attention to the scale. So you can, on that side there, it's going to go, and then you pull it out and you'll see 60, and then you can go up on the one that's pulled out is 1. So 60, 1, 2, 3, 4, 5, 6, 7 is where the meniscus is. So 67 milliliters. And then 68, 69, 70, okay? And then units are ml for milliliters, and 1 milliliter equals 1 centimeter cubed of like volume, which you guys learned about yesterday on Wednesday if you're doing your lessons, as you should be. You learned about that with the lessons over regular shaped objects and how to calculate it. So we just kind of learned how to read a graduated cylinder, so we're going to do a little bit of practice, okay? So for this first one, I kind of did most of the work for you, but those are the 4 steps that you need to take. So 1, measure from the meniscus, which is the lowest point of that liquid. 2, you're going to check your scale and make sure that you understand that it's going by 1s or 2s or 5s or 10s or a decimal even. You're going to count to make sure, and then you're going to double check your answer to make sure that you are correct. So looking at this, it looks like it's 1 tick below 40, so that should be 39, right? No, because the scale is 2. So we can see 30, 32, 34, 36, 38 is where that meniscus hits. Do you see where the water rises up on the sides? And so it actually looks like it's at 40. So if you don't measure by the meniscus, you're going to get a completely different answer than what is correct. Okay, so again, 38 milliliters is the answer to this practice question. Next, this one's a little blurry, but we got it. So again, I'm going to measure from the meniscus over. I'm going to check my scale, and it is by 1s. I'm going to count, so 10, 11, 12 is the meniscus. I'm going to double check my answer, so 10, 11, 12. So it is 12 milliliters. You have to put the unit as well on there, okay? This next one, again, we're going to do kind of Dora the Explorer style. We have the example up. I went ahead and put the arrow for you still to kind of help out. We're still learning how to do this, or maybe trying to remember how to do this. So number 1, you're going to measure from the lowest point. 2, you're going to check your scale. 3, you're going to count. And then 4, you're going to double check your answer. So I'm going to give you a second and stare very awkwardly at you while you do this. Okay, so you should have gotten 110 milliliters, because if we got 100, the scale is by 5, because to get to 100 to 125, with that many dashes, we have to count by 5s. So we've got 100, 105, 110 is where that meniscus hits. And then you can see 115, 120, 125 will get us to the next one, okay? So your answer should have been 110 milliliters. If it wasn't, rewind a little bit, go back through, and double check that you understand how to measure using a graduated cylinder. Because if you don't, when we get to the next couple parts, it's going to get even crazier, okay? So this is a simple skill that you will have to have mastered. So make sure that you understand this before moving on. Now, it's kind of story time. We have bathtub story time with these bathtub problems. So there once was a man, and his name was Billy Bob. Sure, we'll just call him Billy Bob. Billy Bob had a long day at work, and he just wanted to take a nice hot bath and soak so that he didn't feel so old. So Billy Bob fills up his tub, and he fills it to the very brim. I mean, the water is just touching the edge of the tub, and then he cannonballs in. Well, what happens? Yeah, all of the water splashes everywhere out. Well, Billy Bob is super disappointed because he wanted a bath and now half the water is out of the tub and he doesn't understand why. So he gets out and he stares, and then he realizes, oh, it's because he got in too fast. So he, you know, duh, he fills the bathtub all the way back up to the very top, and then he gets in really slow toe, and then the other foot, and then slowly sinks. And as he's slowly getting into the bathtub, that water is slowly spilling out into the floor. So then he slows down even more, slows down. And no matter what he does, him getting in the bathtub, all the water spills out. And he's super confused as to why. He filled all the water up, he's getting in, and now all the water keeps spilling out every time he gets in the bathtub. I bet you already kind of know why. So basically, every time he gets in the bathtub, he realizes it's because he gets in and his body is taking up the space that that water used to take up. So it's pushing the water out, right? So that's why. So now, what's the solution to this? It's so that he fills up the bathtub about halfway full instead of all the way to the very top. He fills it up halfway, and then when he gets in, the water reaches the very edge of the tub. It goes all the way up, and so I guess his body gets into the bathtub. Okay, so that's that's Billy Joe, Billy Bob, whatever name I just randomly picked. Bathtub problems, but also you guys just learned Archimedes Principle. Okay, I found that when we say Archimedes Principle, you guys are like, what? But you know what I'm talking about whenever we talk about it. Archimedes Principle is basically an object immersed or like surrounded by water or a liquid is going to take up the space that that liquid could have taken up. Just like Billy Bob getting in the bathtub makes the water fall out because his body is getting in and taking the space where the water would have, or that volume where the water would have been. So it pushes that water up and out. Now, if Billy Bob had a taller bathtub, that water wouldn't have spilled out, but the water level would have still rose. A really good example of this is also, have you guys ever been to McDonald's or Taco Bell, maybe Wendy's, and gotten a soda? They always fill it, I mean, halfway with ice, right? So do you get more soda if they fill it all with ice and then the soda, or if you ask first no ice? Yeah, if you ask for no ice, you're going to get so much more soda than you would if you have ice. Same thing. That ice is taking up the space or the volume where that liquid could be, so you'll get less liquid because of all that solid taking up the space. So, pro tip: ask for light ice or little ice when you go to your different restaurants and stuff, and you'll get more soda for the same amount. And then also, if you like history and you want to actually know, the version I gave you of Archimedes' Principle and Billy Bob's Bathtub story time is very simple. If you want to know the actual history behind it and like the cool ship that he designed, and how he figured out how to find the volume of a gold crown to see if the king had been shorted his gold bars, then you can click that link at the bottom, and that will tell you kind of the history behind Archimedes as well. So in using Archimedes, we call this displacement. So volume by displacement. Yesterday, you did the volume of a regular shaped object, so you could just calculate it. Well, if you have a dinosaur or a hammer or something, you're not going to be able to just do that like you would with a cube. So we take volume by displacement. So basically, you have an initial water level or the starter water level, and then you have the new water level after you put an object in. Well, why does the water level rise? Yeah, it's because you put an object in there, right? Because you put something in. If you never had, the water level would have remained the same, but now that water level has risen or gone up, And it's because of that object taking up that space and pushing the water level up. So the difference between your initial or your first level of water and your second measure or level of water is going to be the volume of the shape that you've put into it. Okay? Pretty easy, right? We're going to practice here in a second. But first, I went ahead and laid out your equation. This is a little mathy, so if you are not super math-minded, then we're going to get through this together because I'm also not super math-minded. If you are math-minded, then you're going to blow through this and think it's super easy, okay? So the equation, which I would write down or keep kind of in your mind because you're going to need it for practice later, is the volume of an object equals the volume of water after the object minus the volume of water before the object. And then underneath I put like your bigger number and then your smaller number because we don't need a negative. So if you get a negative going through these examples, you've done it incorrectly. Okay? So the volume of water after the object has been placed in, which will be your bigger number, and then the volume of water before the object, which will be your smaller number. Okay? And you subtract those. Here's an example. So I went ahead and put your arrows and I did all the work for you, but let me walk you through. So we've got your equation. The volume of an object equals the volume of water after the object minus the volume before the object. Now the volume after the object, if we look, it looks like we've got 20 and then 21, 22, 23, 24, 25, and then 26, 27, 28, 29. Okay, so 29 is where the meniscus is, that lowest level of water. So 29 is the volume after the object. Well, the volume before the object is going to be smaller. Okay, and so we've got 19. Looks like we've got 20, and we'll count one down. Do you see why it's really important to check your scale? And it's also really important to make sure you're measuring from the meniscus, because if you had measured these incorrectly, you would have gotten a different number for the volumes before. So I went ahead and wrote the equation. So you've got volume of an object, and then I just kind of plugged and chugged, right? So we've got 29 milliliters, which is the volume after the object, minus 19 milliliters, which is the volume before the object. And then if we take those, we minus them. 29 minus 19 is going to equal 10 milliliters. What do we think? Pretty easy? Okay, so if you're struggling a little bit, maybe we go back and watch it again, just this section. I'm going to move on to the next example, and I didn't give you the final object because I'm going to make you do that piece of math on your own. Okay, so I've still got the same setup. You've got your equation at the top, so you don't have to remember it too much. And now we're going to measure from the meniscus. The volume after the object is 68 milliliters. The volume before the object is 64 milliliters. So we've got a scale of 1. And so I counted, double checked. I plugged those numbers into my volume of an object equation. So 68 milliliters minus 64 milliliters. And the volume of the object is 4 milliliters. So 68 minus 4, and you should have gotten 4 milliliters for your answer. I feel very much like Dora the Explorer. I'm pretty excited about it. Okay, so how are we doing? Are we okay? Okay, we have one more example coming up. This example, I gave you nothing. Okay, so I'm going to give you a couple seconds to go through. So remember, you've got your equation at the top. You're going to find the volume after your object and insert it or write it down. Then you're going to find the volume before the object in your graduated cylinder using the meniscus. Check your scale, and then you're going to plug that in. Next, you're going to use your equation. So you want to find the volume of the irregular shaped object, which is this hammer. So you're going to write in the volume after the object minus the number you got for the volume before the object. Then you're going to do a little bit of subtraction. And then you should have the volume of your object. Okay? So the volume after the object is 69 milliliters. The volume before the object is 65 milliliters. When I put them into my equation, so 69 milliliters minus 65 milliliters, the volume of my object should be 4 milliliters. Did you get the same answer? If not, rewind a little bit, and if so, congratulations and great job. Okay, make sure that you understand all the concepts in this video so that when you move on to the handout, you're not totally lost. Okay, and great job.